Good morning, good day, wherever you are. I hope you are doing great and you are all excited about another discussion on statistics or the science of numbers. Numbers are all over the place. People's age, people's income, and everybody wants to get a handle on the numbers because they want to find out what are the characteristics of this number. But think about, I'll give you a practical example of how I use it. Say I'm a statistician, college hires me, find out the average age of all the students at the campus. Can I reach the population? They do not give me enough time and money to do reach the entire population. It's a big population. Minimum 10,000 students. How will I reach 10,000 students? Even if I take one semester, I will not be able to reach the entire population of students to find out what is their average age. Why does the college want to know about the average age? Because if they know about the average age of all the students, they can plan their resources. How many teaching staff do they need? How many academic counselors do they need? They all need to find that information out. Hence, they hired a statistician such as me. Go find out the average age of the entire population of students. Now, I cannot reach the entire population. I do not have the time. So, what do I do in that case? And please bear with me. Please watch the entire video. Do not stop at the middle and quit. And please subscribe to my channel by hitting the red subscribe button. And please, if you like my video, give me a thumbs up. I really appreciate that. That motivates me to produce more interesting videos. So here I go. So instead of working with the entire population, I will work with a part of the population, which is a sample. And this is very practical. This is the way statisticians do their job. They do not cover the entire population. They only work with a part of the population, which is a sample. So one way, easy way, as this slide says, is to work with a sample that is convenient to me. I'm a statistician, I teach at the college. I can always work with the students in my class. I can ask them, what was your age at your last birthday? Give me to me in whole numbers, number of years. 30 students in my class. I add up all the 30 numbers, divide by 30, get the sample mean age. But is that a good sample? Big question. Is that a good question? No, that is not a good question because that sample does not represent the entire population. You ask me why? Because I have not talked with or surveyed students who do not take statistics class at all. Okay. So this is a sample of convenience to me, easily available to me, but does not represent the entire population. Okay. So if I just work in with the sample of students in my class, which is a convenient sample to me, easily available to me, I put some bias. Why do I put some bias or preference? Because I'm working with students who are taking a statistics class because it's a part of their curriculum. But there are other majors such as philosophy major or language major. They do not have to take a statistics class. How would I know what are their ages? So this puts a bias in my analysis. Bias means preference in one direction. Bias can result from the way in which the sample is selected or from the way in which information is obtained once the sample has been chosen. So there are several types of bias: selection bias, which is my bias, then measurement or response bias, and non-response bias. Selection bias is a sample of convenience, is a big example of that. Then we are going to talk about measurement or response bias. When I'm asking them question, and is the question properly worded so that they're answering it correctly? Non-response bias, lot of people in real life, they participate in a survey, but they do not answer all the questions. And that brings into play non-response bias. Selection bias, I already talked about it. The way you select the sample, right? The way you select the sample, if you work with a sample of convenience, that automatically puts a bias in your sample, okay? Because you only work with students who are in your class, for example, okay? Not everybody has to take a statistics class, right? You agree with me, right? Measurement or response bias, as I said, how the question which the participant, when people participate in a survey, they fill out a questionnaire which consists of a number of questions. If the questions are not worded properly, then people will get answer incorrectly, and that will put some bias in the results. And this is coming because the way the question was framed was biased. Okay. And biased means it leads you to answer the question in one way, which may not be the correct answer. Okay. So they give you several examples how there can be response bias based on the questions used in the survey form. Okay. So measurement has bias refers to systematic deviations due to faulty instrument. Now you're talking about where am I using an instrument? Well, the instrument is the question or the questions you have put in your survey. If they're not correctly worded, people will maybe there will be a tendency to answer incorrectly, and that will put some bias in the response or preference in the response. And I already told you about non-response bias. This comes from the fact that not everybody who participates in a survey will answer all the questions. On top of that, everybody you have invited to participate in the survey may not answer, may not at all participate. Okay. And there are some examples of where non-response bias is generated. In mail surveys, in telephone surveys, that's a big example today. If you go by, say, a surveyor, a person who is uh, doing the survey, uses telephone numbers listed telephone numbers. There's a big bias in that. Why? Because not everybody has their telephones listed. And if you have a cell phone, your number is not at all listed. So you're missing people if you're using numbers only, listed numbers. Okay. Personal interviews. Okay. So if you can personally interview each and every participant, that will probably reduce the level of bias because it's one-to-one. If there's a doubt in any question, the people who are participating in the survey can ask the question to clarify the question to the people who's conducting the survey. That is the best possible way of doing surveying so that there is no bias introduced based on the question because they can clarify if there is any doubt in any question. So there are three types of bias. Okay. One is selection bias. An example of that, that if you use telephone numbers to contact people from a list of published numbers, then you are missing the people who are not listed in that list. Most probably, people have cell phone numbers, their numbers are not listed. And as you know, in today's world, majority of the people have telephones, cell phones. Therefore, their numbers are not listed, and you're measuring a big part of the population. Measurement or response bias comes from faulty design of question. Okay. Tendency for samples to differ from population because the method of observation tends to produce values that differ from the true values. Why? Because the questions are not worded correctly. So people who participate in the survey may respond incorrectly. And again, non-response bias, we already talked about it. Lot of people who participate in the survey do not answer all the questions, or some people, although initially they show interest in participating in a survey, they will not answer any question at all. That also produces non-response bias. Again, bias means preference in one direction, and presence of bias will give you incorrect results, and you will not get a true picture of the entire characteristics of the entire population. It is important to understand bias is introduced by the way a sample is selected or by the way data are collected from the sample. Increasing the size of the sample, although possibly desirable for other reasons, does not reduce bias if the method of selecting the sample is flawed. Okay. Okay. So here is an example why people buy from fast food restaurants. Calorie content and menu item selection reported that the average number of calories consumed in lunch in New York City fast food restaurants was 827. The researchers selected 267 fast food locations at random. The paper states that each of these locations, adult customers were approached. This is important. They were approached as they were entering the restaurant and asked to provide their food receipt when exciting and to complete a brief survey. This is important because they were approached as they were entering the fast food restaurant, and then when they said that they will participate in the survey, they were told that at the end, after finishing your lunch or dinner, whatever, please provide me with the receipt so that I know what exactly you consumed. Approaching customers as they entered the restaurant and before they ordered the food may have influenced what they have purchased. This why? Because people know we are participating in a survey, so let's buy foods which are not high in calories. Okay. In addition, some people choose not to participate when approached. Non-response bias. If those who chose not to participate differed from those who did participate, the researchers also need to be concerned about non-response bias. Both of these potential sources of bias limit the researcher's ability to generalize conclusion based on data from this study. Okay. Here you see the word random sampling. Random means without any preference, without any order. We want to select a simple random sample. Why? Because we want to make sure that everybody has an equal chance of getting selected in the population. This way, we will select a sample which will represent the entire population as a whole. Example, to obtain a valid simple random sample of 10 employees from a large design firm, the selection method must ensure equal likelihood for all subsets of 10 employees. It should be selected in such a way that every employee has an equal chance of being selected regardless of employment status. What it means, if everybody has an equal chance of getting selected in that sample, then that sample is a random sample. We are not showing preference to anybody, and that sample most likely will represent the characteristics of the entire population. So here is a definition, formal definition of simple random sample of size n, a sample that is selected from a population in a way that ensures every possible of sample size n has the same chance of being. What does it mean? That means if we select a sample of size 30 from a big population of, say, 10,000 students, now there are many, many samples of size 30 in that population that we can get from that population of 10,000 students. And every sample of size 30 has an equal chance of getting selected. That is the definition of simple random sample of size 30. Now you may wonder why do I need to select a simple random sample and how will I do it? That's a big question. How will I do it? How will I select a simple random sample of size 30 from the population of 10,000 students? That's not easy task. But we know that we need a simple random sample where everybody has an equal chance of getting selected, because then the people who are selected in the sample will represent the entire population. But we are questioning how to do that. In your mind, you're thinking right now, how will I develop a simple random sample of size 30 from this huge population of students? That's a valid question. I appreciate that. I'm excited that you are thinking about it. That how will I achieve it? You understand that we need a random sample and we need a simple process of selecting that sample, because we do not want to show any bias or preference to anybody. Because if we show bias, such as only students selected from this section I'm teaching today, will not represent the entire population. So you appreciate all this, you understand all this, but you just questioning yourself, how will I achieve it? It's a big thing. I mean, 30 students to be selected randomly from a huge population of 10,000 students, not a joke at all. So let's think a little bit about it. Yeah, how to do it? Think for a minute. Can I do some lottery? Probably. What kind of lottery should I do? That's a good question. Remember, everybody should have an equal chance of getting selected. So, in the next few slides, we are going to discuss slowly about this process to make sure that you select a simple random sample of fixed size from the population. First and foremost, what we have to do is to make a sampling frame. What is a frame? That's a good question. Okay. So, we have 10,000 students in the college in this semester, and we can arrange their names alphabetically. Okay? Alphabetically by the last name. A as in apple, next letter A also in the last name, and so forth. So we start with the last name of the students, A as in apple, and move down the list to Z as in zebra. So we have a list of 10,000 students based on their last name, arranged alphabetically in an ascending order from A to Z. So we have a list of students' name. This is called the sampling frame. Why do we need that frame? We need that frame because from that frame, we have a good chance, or list of students, good chance of selecting a simple random sample. Now, the word simple is stuck because we want the process to be simple. We do not want to do too much work to select a sample. The word random is stuck because everybody has an equal chance. Nobody has got any preference to be selected in the sample. Hence the name simple random sample. And we are going to, so here we are talking sense. We have a list of students, names, last names arranged alphabetically, and that is the sampling frame. So we can do two types of things, sampling. We can do with replacement or without replacement. What is with replacement? So we have the list of students, okay? We can select the same students a multiple number of times, rarely used in practice due to potential bias. So we are making a list of students who will put us in from the list of students. Why? We have the big list of main list of students sampling frame from which we'll do a short list of 30 students to be selected at sample. If the same student is selected again and again, that puts a bias in our sample. Same student in the list of 30 students that we are going to form, we're going to form from that entire list of 10,000 students, same student selected again and again puts a bias. We don't want that. That is the first technique, sampling with replacement. Sampling without replacement is used more commonly. What does it mean? Means one student who is selected randomly from that main sampling frame is selected only once. The next time another student is selected, it's a totally different student. Sampling without replacement. What does it help? Prevents potential duplication and maintains randomness. So sampling without replacement is the one that is most preferred. Once an individual from the population is selected for inclusion in the sample, it may not be selected again in the sampling process. A sample selected without replacement includes n different individuals from the population. So n is the sample size. So 30 is our sample size. Suppose then once we randomly select one student out of that sampling frame of 10,000 students, he or she is selected only once in the sample, not to be selected one more time. Then we will work with the remaining 9,999 students and select another student randomly into our sample. And this process continues till we get 30 students selected randomly because our sample size is 30. This is the most preferred method because there is no bias in this, and this is sampling without replacement. We talked about sampling with replacement after one student is selected in the sample from the population frame or sampling frame. We put the student back in the population and again select. That's not going to work. It will introduce bias in our sample. Okay. Although these two, selecting a simple, although these two forms of sampling are different when the sample size n is small relative to the population size, as is often the case, there is little practical difference between them. In practice, two methods can be viewed as equivalent if the sample size is less than 10% of the population. What do they mean in the first rectangle? It means, I'll give a practical example. Think for a minute. I'm going to select a sample of size 30. My small n is 30, 30. What is my population size? 10,000 students. That is my sampling frame. I have a list of students arranged alphabetically based on their last name from A to Z. So think of the number 30. What is 10% of the population of 10,000 students? 1,000. My sample size 30 is much less than 10% of the population, which is 1,000. So what the first rectangle is telling us, it does not matter whether you do sampling with replacement or without replacement. As long as the sample size is less than 10% of the population. And my example, the population is 10,000, 10% of it is 1,000, and my sample size n is 30, which is much smaller than 1,000. So whether I use sampling with replacement or without replacement does not matter. Again, you understand with replacement means once a students is selected to be part of the sample, I can put the student's name back in the population again and redo the selection. That is sampling with replacement. According to the first rectangle, if your sample size is very small compared to 10% of the population, you're fine with either of the methods, sampling with replacement or without replacement. The misconception that a small sample cannot accurately represent the population overlooks the power of random selection. Critics argue that a sample of size like 1,000 from 21.9 million registered voters in California seems inadequate. However, random samples This is the critical thing. What they're saying in this slide, that if your sample size or sample is selected randomly, then the sample size can be as small as 50 from millions of population in California. Why you have confidence in your sample? Because you used a random sampling process to select the sample. So here they're showing the characteristic of the population of 5,000 state university applicants. So on the horizontal axis on the left diagram, this type of diagram is called a frequency histogram. You have the SAT scores on the horizontal axis and the relative frequency on the vertical axis, which they do not show. The rectangles, the heights of each rectangle corresponds to relative frequency in that class. Bottom line, you can join the top roofs of these rectangles to get almost a bell-shaped curve. Again, you're drawing a smooth curve to the roofs of these relative frequency rectangles, vertical rectangles, to get a bell-shaped probability density curve or relative frequency histogram. So this is on the left, you have the histogram of the entire population of students and their SAT scores on the horizontal axis, bell shape because it's the population, huge population size. Now you're drawing samples of different sizes on the right hand side. On the top, you have a sample of size 1000. On the bottom, you have a sample of size 50. You are interested in the center. If you look in the left diagram, look at the number 500 SAT score on the horizontal. That 500, if you draw a vertical line, it has the highest peak of the relative frequency. You need to catch that center. That is your goal. So what you will see, whether your sample size is 1000 or 50, on the right, you are still catching the center 50 in each case. How are you catching the center? Because even look at the lowermost and the one on top of it. If you think of any sample, the center as 500 on the horizontal axis, almost equal on the left of 500, right of 500, in each of these samples of different sizes, 50, 100, 250. So what does this mean? That you can catch the center of the population, which is 500, irrespective of your sample size. You can go all the way from 1000 to as low as 50 and still you will be able to catch the center. The key question here, the key important point that you please understand is that the sample should be selected randomly. It must be a simple random sample. Then the size does not matter. Okay. So there are different ways of doing it. Sampling method. One of it is stratified sampling. What is stratified? It divide the population into different strata or groups. Such as, think of this university. There are four strata or groups of students: freshmen, sophomores, junior, senior. Four strata, divided the students into four strata, then select randomly students from each strata. That is stratified random sampling. Why is this important? Because it is helpful. First, I divide the entire population into strata based on their characteristics, and then from we select randomly sample from each strata. So they're talking about advantages of stratified sampling. Okay. Next, we are going to talk about cluster sampling. What is cluster sampling? Cluster also means groups. Here you're talking about a population of, say, a big city. You can divide it into zip codes. Suppose there are 8 zip codes in the city. In cluster sampling, this each cluster, each zip code. In cluster sampling, you're not going to select all the zip codes, but randomly select 2 zip codes out of the 8 zip codes and then talk to everybody in the selected zip codes. That is called cluster sampling. Okay. Okay. Next, we are going to talk about systematic sampling. What is systematic? As the name implies, there is some system in our selection process. Suppose you are selecting samples coming out of a production line of car. Now there are 100 cars maybe coming out of the production line every day, 100 cars. And we cannot select every 100 cars to check the quality of the final product. You can start with a number, say, as low as 10. So select K10 and then every 10th car after that. So notice if you start at 10th position, select the car coming out at the 10th position, then add another 10 to it, 20th position, another 10 to it, 30th position. You already selected 3 cars, and at the end you will select 10 cars out of 100 cars. That will be a stratified sample. I mean, sorry, systematic sample. And you'll select the quality or check the quality of those 10 selected cars. So here K is equal to 10. Starting point is the 10th car coming out of the production line, and every 10th car after that, which is our K is equal to 10, and it's a example of systematic sampling that is used in the production line to select samples. Convenient sampling, no good, I told you, because it is biased. Sometimes it is used because it's the most easy method to select a sample. And voluntary response sample, voluntary means nobody is forcing anybody to be part of the sample. People out of their own will, they want to participate in a sample. But there's a catch there. What is the catch? People who out of their own will want to participate in a survey, they're voluntary response sample, but they have a biased viewpoint. That's why they want to participate in the survey. Why they have biased viewpoint? Because they want to express either they support strongly the cause or they're against the viewpoint. That's why they want to participate and express their viewpoints. Okay. So we stop here today. If you have any question or comment, please write me a note. If you like this video, please give me a thumbs up. Please express something in your comments. Do you like this video? Where are you watching from? I would like to know where you are watching from. Am I doing a decent job? If I'm doing a decent job, please give me a thumbs up. I really appreciate that. And again, if you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. And do not forget to watch me tomorrow when I'll be back with another interesting video just for you. So again, please subscribe to my channel by hitting the red subscribe button. If you have any question, comment, please write. So I want to know where my audience is coming from. So please let me know that. I appreciate it, and I will look forward to seeing you next time. Thanks for taking the time to watch my video. Take care. Have a nice day.